Okay, let us look at the laws of logarithms. So the first we'll be looking at will be the addition law. So here, under this addition law, let's say for example we have log 25 base 10 plus log 4 base 10. So in this case, the first thing to do is to check if the bases are the same. So here the bases are the same. We have log 10 and log 10 on both sides. So you pick one of the bases, log base 10, pick one of them, and then you multiply the numbers, multiply 25 and 4, and you're multiplying because of the plus sign. So for addition law, we actually multiply the numbers. So we have 25 and we have 4, and we're going to multiply them because we have addition sign here. So multiply them out here. So you write out 25 times 4, 25 times 4, which is 100. So write it out. We now have log 100 to the base 10, because this 25 times 4 actually gives you 100 after multiplying. So now this is not the end of the journey. You ask yourself, 10 raised to the power what will give you this 100, like what we did in the previous video. So let that power you don't know, let it be x. So ask yourself, 10 raised to the power, this unknown must give you 100. So convert it to an exponential equation. So you end up having exactly how you interpreted 10 raised to the power this, write it out, must give you 100. So 10 raised to the power x, write it out that way. 10 raised to the power x equals 100. Then of course you make both sides 10 raised to the power something, since it is now an initial or an exponential equation. So if this 100 becomes 10 raised to the power 2, then still write your 10 raised to the power x equals the 10 raised to the power 2. Then 10 cancels out this 10. You are left with x and 2. So equate them. You write out x equals 2. So definitely log 25 base 10 plus log 4 base 10, if you follow the laws of logarithm strictly, you will definitely get 2 as your answer. So 2 will be your key answer. So let us look at subtraction law. So for this subtraction law, let's see an example. We could have log 28 base 2 minus log 7 base 2. And almost the same thing with the addition. You check if the bases are the same. They are the same, 2 and 2. Then you pick one of them out, write it log base 2. Then the next thing is to divide the number 28 by 7. So divide 28 by 7 because of the negative sign here, because of the subtraction sign here. When it was plus, we multiplied the numbers. But now that it is subtraction, we are going to divide the numbers. So let's divide them. Let me fix them there. You write 28 divided by 7. So, and of course, you're going to get 4. If you divide this 28 by 7, you get 4. So fix it. You end up having log 4 to the base 2. Remember, this actually gave us our 4 here. So that's it. So now, this is not still the end of the journey. Ask yourself, 2 raised to the power what will give 4? Definitely let it be x, since you don't know it. Let that power be x. So then of course 2 raised to the power this x must give you 4. So write it out. 2 raised to the power x equals 4. We are converting into an exponential equation that way. So 2 raised to the power x equals 4. Then you can make both sides 2 raised to the power something. So you write 2 raised to the power x equals 2 raised to the power 2. So these 2 cancels out these 2. Then you are left with x here equals these 2. Write them out. So you have x equals 2. That is to say that log 28 base 2 minus log 7 base 2 will definitely give you 2 as your final answer. Okay, let's go to the next law. This one would be power law. So when the number has a power, what will happen? So let's look at it this way. Imagine you have log 8 raised to the power 3 base 2. So if you have it this way and this number 8 has a power of 3, then the power, which is 3, can move from here and become a can move from here and come over to this side and be in product with the logarithmic expression. So it now becomes something like this. Becomes something like this. Let me clean this one off. Sorry about that. Becomes something like this. 3 log 8 base 2. So the power has definitely moved and come over to this side. It's now in product with the log. So in this case, it is now, you could also rewrite it like this: 3 times log 8 base 2. So that is to say 3 times whatever you get when you evaluate this. So we could actually solve this question in 2 ways. We could do it this way. We could just say, okay, let's split the screen. So imagine if we had it this way: 3 log 8 base 2, and we had it the way it was before, log 8 raised to the power 3 base 2, and we could still solve this one. The question still is 2 raised to the power what? That's if you want to evaluate this. 2 raised to the power what will give you 8 raised to the power 3. You will just equate it to x. Since you don't know it, let that power be x. And of course, we know that this 2 raised to the power this x must give us the whole number here, the whole 8 raised to the power 3. So that converts into an exponential equation. Then we'll have 2 raised to the power x equals 8 raised to the power 3. Then we could make them have, you can make both sides 2 raised to the power something. So this one becomes 2 raised to the power x. Then 8 becomes 2 raised to the power 3. Then still the same 3 that is there as the power still comes back. This 3 still comes back as the power here. Then you now open the bracket by multiplying the power inside by the power outside. So you end up having 2 raised to the power x equals 2 raised to the power 9, because this 3 times this 3 gives you 9. So 2 can now finally cancel out 2. Then you have x. You now have x equals 9. This is method 1. Then method 2, if we come back to this side, if we decide not to let this 3 remain as the power of 8, you want to do it this way. You've already moved the 3, just like how I moved it here. Move the 3 over to this side. So it is possible to solve it this way. So in this case, after solving, we will still get this same 9 as our answer. It is your choice. So let's solve it now and see what we're going to get. So in this case, it is actually, this one means 3 times log 8 base 2. So now we're going to focus our attention here and simplify only this one. So simplifying only that one, we're going to ask ourselves 2 raised to the power what will give 8. Of course, we don't know it, so let it be x. So let's equate that power to x. So it becomes 2 raised to the power x equals 8. We can have 2 raised to the power x equals 2 raised to the power 3. Yes, 8 can become 2 raised to the power 3, because both sides must be 2 raised to the power something. Then, of course, this 2 can cancel out this 2. Then we are left with just the x and 3. So we'll just say x equals 3. So now that we've got 3, we still have this value here waiting for us. So this 3 must be multiplied with whatever you get after simplifying this. And after simplifying that, what did we get? We got 3. So write out the 3. This 3 times this other 3 here waiting for us. So times 3, and we'll get 9. So exactly what we got before. So that's it. Very easy. So the next law will now be power law. Okay, I think we've done the power law. The next one will be power of the base. Yes, this is power of the base. So what if the base has a power? So let's look at it this way. Imagine if you have log 16 base 2 raised to power 3. So now that the base has a power of 3, and in the same way we did the other one, the power can move over to this side and be in product with the whole logarithmic expression also. But in this case, if the power is moving over to that side, it is going to invert and become 1 over 3. Yes, so we'll now write it this way: log 16 base 2, then we'll have 1 over 3 on this side of the logarithmic expression, because the power is going to invert when it comes there. And we can now solve this one exactly how we solved the previous example. You can solve it directly this way, or you could leave it this way and solve. So that's it. So imagine if the base has a power of, let's see another question, log k, and the base is m, and the m has a power of b over a. So again, the power of the base will leave and become here and be in product with the whole logarithmic expression. So we end up having, when it moves, we now have a over b log k base m. So this will now be the new expression. Then we can solve. So that's it. So very simple. Then the next law will be reciprocal law. For this reciprocal law, imagine if you have this expression, log 5 to the base 8, and your wish is to swap the two of them. Your wish is to make 5 the base and make 8 the number. So the only way you can swap this is if you apply reciprocal law. And what's reciprocal law? You are going to introduce 1. You simply write 1 divided by, then it swaps automatically, log 8 base 5. Once you place the 1 on top, or once you divide 1 by this expression, the number and the base swaps each other. So now, if you notice, the 5 is now the base, and the base that was 8 before is now the number. So that's it. Even if you have this one this way, see another one here, you have log 4 base 10, and you wish for the 10 to be the 4 to be the base and the 10 to be the number. Just apply this reciprocal law, just fix 1 there. So you now have 1 over, anything you're writing now must swap the values. So once you place this one, you are now allowed to write, log 10 base 4. The numbers will now swap each other. So that is it. The 4 now becomes the base, and the base now becomes the number. So that is reciprocal law for you. So now let's go to change of base. Change of base will be the next one. So change of base is very easy. So if you have something like this, well, let's now find out why change of base is very important. Imagine they gave you log 5 base 7 and they said you should simplify. Of course, how do you simplify this? You're going to find out 7 raised to the power what we give 5. So you don't know it, let that power be x. So write it equals x. So 7 raised to the power x must give 5. What's that value? Write it out and let it look like an exponential equation. You will now write 7 raised to the power x equals 5. But in this case, you want to make both sides 7 raised power something or 5 raised power something, which we know it is never possible. So what you're going to do is you're going to now go back to the original question and apply change of base. That will be your game changer. So going back to the original question, I can now rewrite it log 5 base 7 equals x. Then the next thing to do is to give both log 5 and log 7 separate bases. Not actually separate bases, give them the same base, like this. You will now have something like this. You write them this way. You write log 5 base 10. See, I'm giving both of them base 10 divided by, I'll also write log 7. Write log 7 and give it base 10. Why am I giving it base 10? Base 10 is the common logarithm, and you can, if a particular logarithm is in base 10, you can use your calculator to further evaluate that number if it is in base 10. For example, imagine if you have this log 7 base 10 and log 7 base 2. I can use my calculator to evaluate this. Why? Because it is in base 10. But I can't use my calculator to evaluate this straight up until I apply change of base on this one. But I don't need change of base for this one because it is in base 10. I'll just pick my calculator and punch in log 7 and then maybe round off the decimal value to like 4 decimal places, and that's the value I'll put down for my log 7. But this other part here, I just have to use change of base because the base is in base 2 and not in base 10. So that is the idea here. That is why in this particular one we are giving both the log 5 base 10 and the log 7 base 10, so that we can now finally use our calculators. So we now have, then still place your equals x, then you can now use your calculator. So for the numerator, which is log 5, it is now in base 10. I gave it base 10. I can now use my calculator and I'll just type in log 5, and that will be 0.6990. So that'll be 0.6990. So writing that one out, I'll have 0.6990 divided by, I'll punch in log 7 also because it is in base 10. It is allowed. I can do that because it has base 10. So log 7 gives me 0.8451. 0.8451 then equals x. Then I can now divide the values. I can now divide 0. As you can see, I'm rounding off to the nearest 4 decimal places. It has to look as if you are using your 4-figure table. So let's now divide the values. 0.69 0.6990 divided by 0.8451. That will give me 0.8271. So finally I have 0.8271. Then I could just say I could just say x is approximately 0.83. I could do it this way. So that's it. So when you are stuck with a particular problem, like this one where we could not simplify further, where we could not make 7 raised by something, and we could not make 7 5 raised by something, we have to switch back to the original question here. Yes, so we went back to the original question and we applied change of base here. So that's it. That's why change of base is very, very important. So they could give you another question again, maybe this way. They could give you again log 3 base 2, and you now say, okay, 2 raised by what? You want to try, you want to simplify again. You ask yourself, 2 raised by what gives 3? Okay, let that power be x. And you want to solve the normal way. You now say 2 raised by x must give 3. You write it out to form the initial equation you need. 2 raised by x equals 3. And again, you get stuck here because you know that you cannot make both sides 2 raised by something or 3 raised by something. Then don't be afraid. Then you just have to apply change of base. So apply change of base. How? Just write out the question again. Log 3 base 2 equals x. Then apply the change of base. Now, how will you do that? Write log 3 and give it base 10 because it's very important for you to give it base 10. Divided by, again, write log 2 also and give it base 10. The bases must be the same. Log 2 and give it base 10. So that is it. The bases must be the same. This here I have base 10 and I have base 10. If you are giving base 5, let this one be base 5 and let this one be base 5. That's what they call change of base. I'm not saying it must be 10 all the time. I'm just saying that any base you choose to give to the number, let it be in unison. Let it be for the numerator and for the denominator. So now, equals x. Then we now use our calculator. It can work for us now because this is in base 10 and this is also in base 10. It's possible. So just punch your calculator. We're going to have log 3, and definitely log 3 equals 0.4771. So this log 3 will give me 0.4771. 0.4771 divided by log 2 is going to give me 0.3010. 0.3010. Then you place your equals x again down here, equals x. Then you further simplify by dividing the values. So 0.4771 divided by 0.3010 gives me 1.5851. So x equals to 1.58. But let me write this properly. 1.5851. So we could now round up to, let's say, 2 decimal places. So I want to end up having x is approximately 1.59 to 2 decimal places. While this one, we also rounded up to 2 decimal places also. 2 decimal places. So that's it. This is just the basic idea. So in the next video we could go further and solve harder examples and still follow the laws of logarithm. Very interesting topic if you can follow strictly the laws and have the basic idea of your algebra indices. So that's it.